Yeah. Hi, good evening, everyone. I hope all are doing good at this time of Ramadan. Myself, Deepu Ravi Kumar, Chair of IIRSM Qatar branch. So I will be delivering a session on scaffold awareness, safety requirements. So just a moment, let me share the presentation. Yeah. So we will be talking about scaffold awareness, as I said. So I believe all are aware about scaffolds. Nowadays, it's widely we have been using, and from long time we have changed from one equipment to other equipment. Like early days, many of them has been used bamboos to erect temporary height platforms. So scaffold is an elevated temporary work platform, and now it has been so advanced, and now we have so many different types of scaffold which is available in market. So as per our job and locations, we can decide which kind of material is required. So in today's section, I'm not going too deep on this topic because, as you know, scaffold is a big topic. If we start to talk, we can talk a lot. So we will be talking a little bit portion about scaffold, and I will be covering a little bit about platforms. So scaffold, as I discussed, an elevated temporary work platform. So in heights, we require platforms where our people can stand safe and they can work safely without any risk. So scaffold is the one solution which we have. So when we talk about scaffold, we have huge different types of materials is available in market. Like most of us are familiarized with tube and clamps, which I like a lot about tube and clamps. As per our design and location, we can play with it. That's what I always used to say. Building a tube and clamp scaffold is like a art. I always used to say, even in my training sessions, because as per the design, we can change a lot of things as per our requirements. We can compromise and we can add a lot of things in that. So that is two-band clamps. Then we have cup lock, another wide range one which most of us has been using nowadays. I can say it as a system scaffold because when it comes on scaffold, we have different standards which we have been following. For two-band clamps, we have 12811 and we have 12810 for system scaffolds. And we have aluminum frames where we'll be following BSEN 1004. So in system scaffold, we have quick stage scaffold, which we have also been using widely. And another type which we have is a ring lock scaffold. Then other one is frame scaffold and comes aluminum scaffold. So we have different types of materials. With this material, we have been erecting different form of structures, right? Independent, tower, footlock, like that, right? So we can generally we can say those are supported scaffold, which we have supports from the ground itself. So we have to start the inspection from the ground level itself, as we always used to say, to make a strong and sound scaffold. Then, as I said, different forms of scaffold. We can use these materials and we can create different types of scaffolds. So one of them is independent tight scaffold. Independently, with the help of tubes, vertical tubes, that is standards, bracings, ledgers, we can erect big scaffold. And most commonly, we can see in sites like the big length, it will be 10 meters, 15 meters, with 5 meters, 6 meter heights. So independently, we can erect it as well. Then we have birdcage scaffold, the lengthwise and widthwise big structure. It will be huge that we can have multiple access from different places and big platform will be there. This will be birdcage scaffold. Then we have tower scaffolds, which we can say it as a single bay or single uh, structure with a pair of tubes. We can erect with we can have multiple lifts over here with multiple platforms. Then we have aluminum structures, mobile scaffold. Again, in mobile scaffold also nowadays, as per the standards, we have different types. Even we can erect staircase aluminum towers, bridge aluminum covers, cantilever aluminum towers are available in markets. Podium steps as per our height requirements. Easy to install, lightweight, like that. So this scaffold, we have different types. So most of the time we can see many accidents has been happening a lot. So when we see accident records, most commonly we used to say more than 60% or more than 40%. Most common reason of fatality in sites is falling from height, falls. So when we look into falls, one thing is also scaffold, falls from scaffold or scaffold collapse, right? So we can hear a lot of news like that. So fatality reason. And another thing also, major injuries, fall from height can lead to major injuries, permanent disabilities. Maybe the person will be on bed for the whole life. So when we look into the incident rates, we can see huge number of accidents has been happening, and many people has been suffered. So what is the reason behind these accidents? So one of the reason I can say, lack of supervision by competent persons. We have people who knows how to erect, but after a certain time period, people will be overconfident and they may skip something, or they may be busy at the job. So we need good supervision. Competent person has to be there to supervise this erection, dismantle of scaffold inspection, and everything has to be done by competent persons. Or else I can say improper scaffold platform construction. Platforms has been erected but improper way. Like boards, platform boards has to be in good condition as per the standards. No pain, no cracks, no damages, and adequate number of supports. I can say transforms, and we need to avoid slip and trips over there. So we need to avoid overlapping. So improper construction of scaffold platforms is happening. Improper dismantling procedures. Again, another most common thing. People are taking big struggle to erect the scaffold. While it comes on dismantling, it is easy for them. They used to dismantle, just remove the clogs, put, using the hammers. So when they're not following the proper procedures, it can lead to accidents. So there is a risk factor where we need to look into. So there is a proper way how they need to erect and dismantle scaffolds properly. Then inadequate fall protections. Yes. In scaffolds also we need to use fall protections. Right. One of the example I can say collective fall protections like guardrail, or else we have to use the harnesses. So there are certain limitations also when you use harnesses. So we need to look into those things as well. So where to use the fall protections, we need to consider the location and all those things, and we need to choose it wisely. Many places we can see people are not using proper fall protection. For example, I can say guardrail. People will be removing guardrail because it will be interfering on their work. So they will be removing guardrails and they will be working or leaning on the scaffold and accidents are happening. Then another common stuff is poor scaffold access. Like we can see, like circus, people has been climbing on scaffold through bracings, tubes, now using proper access. So standard has clearly given us how to create proper access on scaffolds, right? We have ladders, we can use vertical access, right? We can install the ladders internally inside the platform or outside the platform. And even in ladders, we have different forms of ladders nowadays. Step ladders are available, a lot of ones are there. So we need to look into those and we need to create a good access for our people. Then inadequate footings, foundations, I can say. Foundations, like many places we have witnessed, people will be using big bricks or concrete blocks, and above that they will be installing scaffolds. It's not good enough. We have to identify the load over there. We can simply say the scaffold has a dead load. The tubes, planks, all those things has weight, so it will be coming to one particular location, and if that place couldn't hold that weight, accidents, it can lead to accidents. Improper planks, scaffold planks, we need to install it correctly. So planks we'll be using in different places, as a toe board, as a scaffold platform, as a sole board. So there are requirements which we have to follow. So when we are not following the things, which is leading to accidents. So what are the things we need to consider? We have a lot of guidelines which is available. Like I can say one thing which we are following here in Qatar is QCS 14. QCS 14 section 11 part 1.03 for that height. Over there they have clearly mentioned what are the things we need to look into. And also we can look into standards, BSEN 12811, BSEN 12810. They have clearly given us the guidelines how to make a good scaffold structure and what are the requirements which we need to follow. So what are the considerations, right? So before erection of any scaffold, we need to look into some points. Like why we need to erect the scaffold over? What is the purpose? What is the scaffold is for? Like we have different types of activities happening over there. Some places I have seen, witnessed, they have erected scaffold to load the material. So that will be not a normal scaffold. That will be called as loading bay then. So it requires design, calculations, and we need to make sure the scaffold can hold that load over there. So what is the purpose? We need to look into that. Or else what kind of activity we are going to do over there? Is it a small painting job? Or do we need to take huge amount of materials over there? So we can decide which kind of scaffold we require, whether it is a light duty, medium duty, heavy duty. So we need to look into why we require a scaffold over there. Then, is it as per the standards? Widely, worldwide, we have been following NASE guidelines, TG20, right? So we can look into that. Is it as per the standards, right? So the scaffold we are going to erect, where we are going to erect the scaffold, the condition over there, the ground condition, environment condition, the structures over there. So we need to look into those. What kind of material we need to use? What materials are to be used? Is it tube and clamp, couplock, frame, quick stage, aluminum towers? Each type of material has their own advantages and disadvantages. I can say system scaffold, when we use couplock, quick stage, ring locks, we have a lot of advantages also over there. But at the same time, we have a lot of disadvantages also. Like when we mix one part, we require the same part over there. Like we mix a transform. We need the same material over there because it's always better to avoid mixing materials. Because when we mix materials, it will be affect the scaffold structure. That's the reason I always love tube and clamps. Right? So we can look into those and we have to erect it. So what kind of material is required? Depend upon the location, convenience, we need to choose which kind of material we require. Can safe access, right? So another thing we need to look into. While erecting the scaffold, is it suitable to provide safe access? Or while using the scaffold, can we provide a safe access over there? There is another part which we need to look into. And how many working platforms? Like working platforms is another one good stuff which we always need to discuss. When we erect scaffold, we can have different lifts, 10 lifts or 15 lifts, 20 lifts. Scaffolds will be there. As per the requirements in each lift or each 2 meter, we will be having platforms. So in a scaffold, when we erect, let's say 5 lifts and all the lifts has platforms, means 5 platforms are there. So it doesn't mean that all 5 platforms has to be working platforms. So how many working platforms we require? We need to look into those as well, right? So working platforms, we need to look into that as per the capacity of the scaffold. We need to decide one full work platform and another 50% of working platform. Ground condition, again, another main thing which we need to look into. What is the condition of the ground? So depend on that, we can choose the material also, right? Tube and clamps, couplocks are heavy materials. At the same time, when we compare with aluminium, the weight is very less. So how much dead load is going to be over there? Live load, impact load, environment loads, which we need to consider also over there. Then the ground condition, how is it loose one or is it compact one? Condition as per the condition of the ground, we have to choose the sole board. The sizes of the sole board has to be chosen. Either it has to be 1000 centimeters square or it has to be 1700 centimeters square. So always it's good to choose the ground conditions. Many places we may have ground with concretes, but again we need to check the concrete level, how deep it is, right? So we need to avoid accidents. And how and where can the scaffolds be tied in? Another main thing in scaffold, when we erect the scaffold, when the height ratio exceeds from the base ratio, we need to tie the scaffold. So we have different types of tie systems. We can have outriggers, or else we can say it as rackers. We have to provide those. So is it possible for us to provide tie over there? Do we have an adjacent structure? And if we don't have an adjacent structure, we need to install buttress, rackers, and all over there. So how and where we need to look into those. As per the requirements, when the height goes 4 times from the smallest width of the scaffold, we require tie every 4 meter vertical and horizontal, or I can say every 16 meter square we require tie. So do we have suitable location over there? Which kind of tie system we need to adapt? Heavy duty, light duty types are there. So we need to look into those. What bracing required? We have different types of bracings over there: horizontal bracing, vertical bracings, zigzag, X bracings, plant bracings, wing bracings. So which kind of bracings required over there? The more bracing, the scaffold will become more sound. And what load will be imposed upon the working platform? We need to look into that, how much load is going to be there on the working platform. Like one of the mistakes in some places which I have noticed, scaffold has been erected and they will check which kind of scaffold it is. Okay, light duty, medium duty, heavy duty. Okay, medium duty it is. Okay, 200 kg per meter square. That is the capacity. So someone will do a small calculation. Okay, this is the length of the scaffold, this is the width of the scaffold. So total area is this. Okay, multiply this. So this is the total capacity. And they will keep that load in what particular location and actions will happen. So we need to look into that load. It has to be equally spreaded. When we say capacities, we used to say kg per meter square. So every meter square, the weight has to be distributed, or else we need to erect loading base scaffolds with bridges and a lot of bracings and all. So how much load? We need to look into that. Live load. Live load, the person, how many persons has to stand over there, and what materials they are going to carry over there, and what are the tools they are going to carry over there. And not only on the platform, even in the whole scaffold also, we need to look how much live load is going to be there. Will it be sheeted? If it is sheeted, the wind load is going to be huge. Even the scaffold can collapse if we didn't calculate the wind. So these are the questions, not limited to, we have to ask and we need to check whether we can erect a safer scaffold over there. So those are the things we need to look into. So when we say the ground level, so the scaffold always starts with base plate and base jacks, right? Or else I can say beneath that we have sole board also. Scaffold plank itself we will be using over there, and above that we will be having base plates, base jack, which is required on scaffolds. So the load will be spread equally on all the sides. So base plates we need to use to spread the load on the standards to a greater area. Base jacks, which is required to adjust the tubes. Especially we require base jacks on cup lock, hook stage, ring lock scaffolds. We require base jacks. So due to the ground condition, maybe we need to level up over there. And always we need to remember about base jack is we have to use base jack to just to level the bottom ledger, not to increase the height of the platform or height of the scaffold. That is one thing which we need to always remember. Then other components in tube and clamps which we use, different types of clamps. Right, one over here, the first picture on the left side, right angle coupler, which we have been using on tube and clamps for to connecting vertical and horizontal pipes. Or some people used to say, most common name over here I can see here about that is double clamp. Yeah, the capacity is really high, depend upon which class it is. Is it class A, class B? Depend on that the capacity will be. Then we have swivel clamps which we will be using on bracings. And we have single clamp, or we can say it as called put lock coupler, where we'll be using on transforms. We have joint box, or we can say sleeve couplers, where we'll be using to connect the tubes to increase the height. So each coupler has purpose where we have to use it. So we need to identify the correct location, we have to use those. If we accidentally used the swivel clamp instead of right angle coupler, it's not going to help us. So we need to look into those things as well. Instead of using right angle coupler, and we are using single clamp or put lock coupler, is not going to help us. These things will make the scaffold weaker. So we need to look into the site condition. We need to look into which kind of scaffold we are erecting, how much load is going to be there, and we need to follow the proper procedure how to erect the scaffold. So the scaffold components, as I said earlier, it starts with sole board. Depend upon the ground condition, we have to choose the size of sole board. Most common practice is we will be having a bigger sole board where we will be installing two standards on the planks. is a really good one. Or else, if we are going to cut the boards as a small sole board, we need to look into the standards 12811. Even in QCS 14, they have clearly mentioned what should be the size of the sole board if it is loose ground condition or hard ground condition. Then above that, we will be having base plates and we will be having standards. So vertical pipe, standard. Then we have horizontal pipes where we can have ledges, transforms will be connected over there. Then we have connectors on the scaffold, bracing, side bracings, packet bracings, horizontal bracings we will be having. Then the platforms depend upon which kind of scaffold, light duty, medium duty, heavy duty, we have to decide the platforms, how many platform is going to be, because if it is light duty scaffold, we don't want a huge amount of boards over there because the capacity is going to be affected on the scaffold. So while we install the boards, we supposed to have guardrails, top rail, mid rail, toe boards, and tie. If the scaffold height exceeds from the smallest base ratio width, we need to recure tie. So we have different types of tie systems over there. Right? So as I said, sole board, base plates, standards, transforms, ledges, bracings, packet bracings, horizontal bracings, scaffold planks, guardrail, toe board, intermediate or mid rail, guardrail, top rail, and if we are going to store any materials over there, we can have brick guards so we can avoid this material falls on the ground. Tie, we have different types of tie, thorough tie, reveal tie, ring locks. So this is the basic elements of a scaffold structure. So most common question is whether we require design to erect this scaffold. Yes, if it is a complicated scaffold, whether we have huge amount of load which have to be placed over there, or else we have huge amount of wind load, and if the scaffold height is too much, and we are going to erect this, we are going to keep the scaffold over there for long term, it's always recommended to have a design of the scaffold. If we have a design of the scaffold, there will be a proper calculation will be done over there, which will be done by structural engineers, the competent persons, and we will be having a safer scaffold. So the guardrail, as most of us are aware about the structure, right? Top rail has to be minimum height from the platform is 950 millimeter, and toe board, which will be 150 millimeter height, and the gap between the mid rail, top rail, on the mid rail or the toe board will be the maximum of 470 mm. So those are the things mainly we need to look into over here. So another part over here in guardrail which we need to look into is the couplers which will be connecting over here in the top rail, mid rail, and all. It's always preferred to use double clamp over there because the capacity will be huge. Many places we have witnessed that we will be using single clamps over there. So if we use single clamp, the capacity won't be there for single couplers. The capacity is very less, 53 kg approximately, I believe the capacity of single clamp is. So it's not adequate enough as per the standards. So always we need to erect the scaffold in good condition, and we need to make sure the fall protection, the guardrail system, or else in collective fall protections has to be installed in correct way. If we have a collective fall protection, it is going to protect each and every person who is going to stand in that platform. So always we need to look into that. Then scaffold boards. So we can talk about scaffold boards. The standard which we are following is BS 2482 standards. So scaffold boards normally, which we can see over here, it's 225 millimeter wide. As per the standard, they say it should not be less than 220 millimeter wide, and the thickness of the scaffold has to be 35 mm. Again, as per the standards, we have different types of planks which is available in the market, which we will be looking in further slides. So we need to inspect the scaffold boards. We need to check is there any splits, any oil, concrete, paint, any damages are there. We need to look into that. paint concretes and why we need to remove those, why it's not allowed in the boards. The main reason is if paint and concretes are there, we can't identify the cracks. So always we need to make sure those boards has to be cleaned. Like one of the experience I had when I went for inspecting a scaffold is concrete was there, huge amount of concrete. So I asked the erectors to remove the board and we need to install another one. So when I went down and after a few minutes, when I went back to check again, I can found that concrete was not there. They have changed the board. I was so happy. I appreciated them. While going down on the scaffold from the bottom, I looked upwards to check how the condition of the board from the bottom level. And I'm shocked to find out that they just changed the board up down. The main reason behind is they are not aware why it has to be changed, because for them they believe that the main reason why I asked them to change the board because it was concrete paint, they think there will be slip hazard. They are not aware, they didn't think that there can be a crack and it will be hidden, right? So that is another awareness which we need to give among our people, right? So no paints, no concrete, no damages. Always we need to check the board, is it as per the standard? There should be banded, nail plated at the end of the board. If it is as per 2482 standard, it will be nail plated. And we need to support the boards. That is also another stuff. As per the thickness of the board, we need to decide the transform, the support on the board. The maximum, as per the standard, if you ask, it can go from 1.2 meter to 1.5 meter distance. But again, we need to check the scaffold, what kind of scaffold we are going to erect. If it is a heavy duty scaffold, 1.2 meter, 1.5 meter is not allowed. It has to be 900 millimeter, the transforms. So we need to look into those. Then the support, when we keep the boards in support over there, we need to check the overhang. If a board is placed and is being supported, it has to be properly supported, it has to be tied, because in case if any wind, if it is not properly tied, it can remove from the support. And the overhang from the support, we need to check how much distance is went out. So in further slides with the picture, we will look into those. So we need to guard our boards from uplifting due to wind. So we have board clamps, BRCs, which is available. We can use to grab our boards over there. So these are the different types of boards which is available as per BS 2482. Softwood, nail plated. The nail plated to 38 mm to 25 mm board is widely available here in Qatar. Composite plastic boards, very rare I have seen over here in Qatar. Then we have laminated veneer lumber. So depend upon which type of board we use, we need to be careful on the support, the transforms, or else we have to stick on the rule. For the heavy duty 900 millimeter and the maximum for light duty, medium duty or general purpose, maximum distance of transform is 1.2 meter. Or we need to have scaffold calculations drawing and we need to follow that diagram on the supports. So these are the damages which commonly happens. So one of the another main thing which we have witnessed in sites is we will be using the same scaffold boards as sole boards beneath the base plate. And while dismantling, the erectors are not giving too much concentration over there. They will mix the boards all together. The sole board which we have used beneath the base plate will be mixed with the platform boards. So we need to remember the board which we have placed under the base plate already become weak and it has taken too much load over there. The entire scaffold load has been held on that board. So it's always better not to use those boards back on platforms. So we need to inspect and we need to keep the board separate. And always we need to check, is it heavily soiled? Is it rotten? What kind of damages are there? And due to our weather conditions, sometimes board can get bent, bow, crow, king, cup shape. So if those kind of shapes, if we found, we need to remove it. Another common practice which we can see as it's so notched boards. Normally we used to say we are not allowed to cut the boards because the moment we cut the boards, we are going to lose the integrity. So over here, as you can see, they have cut the board, they have used this notched board over there and they kept it over there. So In this practice, I always used to suggest on the both side of the board near to the cut place, we need to give extra support to hold the board or else it is going to break easily. Then nails, spit, cuts, we need to avoid those damages in our scaffold boards. We need to always inspect. So this is the chart as per the standard. As per the thickness, the transform distance and the overhang, minimum and maximum overhang. So in the first line, BS248 to timber board, as per the thickness 38 mm. The load class 1 to 3, that means very light duty, and general purpose, that is medium scaffold. We can have the maximum transform distance of 1.2 meter. And in load class 4, that is heavy duty, we can have 0.9 meter. Overhang, the board comes after the support, the overhang. We need to reduce it. Minimum 50 mm overhang has to be there and the maximum of 150 mm. Or else we need to support the board very clearly over there. And if it's as per BS248 to timber board machine graded 38 mm, we can have the transform distance of 1.5 meter. So depend upon the board. So we have to check with the supplier, and we need to get the data sheet, which kind of board it is and what should be the measurement, what type of distance we need to maintain. So in platform, once we erect the platform, as per the legal requirement, we always used to say the platform, working platform has to be minimum of 600 millimeter width has to be there. So if a person is working over there, it has to be minimum 600 millimeter, so the person can work and walk clearly over there. Minimum of 600 millimeter means we need to have at least minimum of 3 boards. I believe in the old standards or in QCS 10, I believe it's mentioned as 2 boards. So it has been changed. It has to be 600 millimeter. Are we allowed to reduce lesser than 600 millimeter? That is another question which we used to ask. Depend upon the site condition. If we couldn't able to install 3 boards, that is the thing says. The regulation says like that. The standards mentioned it clearly. If you can't install 3 boards, if the place due to the location, we can make the platform width lesser. But the person who stands over there has to be protected with fall protections, collective protections and harnesses and those things. And if a person is standing on the platform and we are going to store materials over there for the work, actually storing materials are not good for platforms. So we are allowed to take materials only as per our job. We need to reduce the load and we need to carry over there. So if we are storing materials, as it shows in the picture, always make sure minimum of 430 millimeter clearance is there for the person to move around freely. Then the gap between the platform and the structure, the building, as it shows in this picture. If it is less than 225 mm is always safer. If it goes more than 225 mm, always we need to use fall protection devices as it shows in the other pictures. Guardrail harnesses has to be used. Fall restraint method has to be followed over there, or fall arrest system has to be followed over there in those platforms. So the gap from the building and the platform is maximum. It should be lesser than 225 mm. It says more than 225 mm means we can install other boards over there. Platform width can be increased. So where it's required as per our job, as it shows in this picture, we need to bring the platform down or up from the in the gap between the structure and the scaffold. We can have inside boards. Oh, sorry. Yeah, we can have inside boards. So as per the legal requirements, the maximum distance from the platform, the inside board, down or up, can be maximum of 500, right? So 0.5 meter, maximum distance it can be. And inside boards, the maximum board which we are allowed to install, it's 2 board. 2 scaffold boards we can install in inside board. And the capacity of this inside board is different. It's not as same as scaffold. Like scaffold, we have erected light duty, medium duty, heavy duty. The capacity is going to be vary. But inside board, as per the regular requirement, it is going to be 75 kg per meter square. Example, we are erected a heavy duty scaffold where our capacity is 250 kg per meter square, which we have following over here. And when we have installed the inside board, the capacity will be inside board capacity will be 75 kg per meter square. And we are a maximum of 2 boards we can use it over there for inside boards. So in the platform overhang, so this is the picture which I have been looking into. The support, the transform has been installed beneath the board. So the minimum distance of the board from the transform is 50 mm, and the maximum distance, I can say, it should be 4 times from the thickness of the board. That is the standard has clearly mentioned 4 times from the thickness of the board, or else we can say we are using a 38 mm thickness board, then the overhang will be minimum 50 mm and maximum of 150 mm. And in the platforms, we will be having openings for access. We will be installing ladders. That is always the safest way. Installing ladders inside the platform is always the safest one. So when we install ladders, the ladder hole, as per the requirements, we used to say is 450 mm wide, and at the other side should not be less than 600 mm. So that is the size of ladder hole where we have been placing ladder. And the landing area, while we accessing the ladder and when we are landing on the platform has to be minimum of 2 boards wide. That is 450 mm. That is the measurement which has been given. So this is the accessing, opening and landing platform. Opening is 450 into 600 mm and the landing platform is 450 millimeter. And always we need to make sure the access path has been stopped from fall hazards like trap door we can use, or else as it shows in the picture, we can use swivel coupler and we can create a gate over there. So once the person enters, he can close it back and we can avoid fall over there. Then always we need to inspect the scaffold. Right? We have tags. So the competent person, the person who has been trained and experienced as scaffold inspector, is authorized to inspect the scaffold and he will be installing tags. And tags always has to be installed near to the access area. I have found in many places they have placed tags in different other part of the scaffold, not near to the access. So it's not a good practice. Always good practice is to install the tag near to the ladder. And the colors, we have red, green, yellow. Red tag where the scaffold is not completed or is under construction, or if it is not safe, we have to be used red grade. If the scaffold is safer, once it's inspected, the scaffold inspector will fill up the green side of the tag, his name, location, ID number of the tag, and which kind of scaffold it is. Is it light duty, 150 kg per meter square capacity, or is it general purpose, medium duty, 200 kg per meter square, or is it heavy duty scaffold where the capacity is 250 kg per meter square, or maybe the scaffold is very light duty, that is 75 kg per meter square, or we have entered this scaffold as per a design where the capacity is higher. So we will be mentioning that. And the scaffold inspector will be signed the tag and he will install the green tag. And the scaffold has to be inspected every 7 days. And in between, any changes in the scaffold, alternation, repair, or weather condition has changed, heavy wind, rainy, which can affect the integrity of scaffold, the scaffold has to be inspected again. So that's the legal requirement, which we need to always follow in scaffolds. So yeah, that's it, the presentation which I have prepared. I would have added a lot, but again, due to the timing, I haven't added a lot. But if you have any questions, please feel free to ask in question tab or in chat box.
We don't.
So any questions?
We don't currently have any questions unless anyone wants to ask them now. No. Oh, hang on a sec. I think we might have one here. Could you elaborate about the base height ratio, please?
Yeah, that is great. Let's take a picture over there to allow height ratio. Just a moment.
If anyone else has any questions, please feel free to ask them now.
Yeah, got the presentation. Yeah. Let me share this page. Yeah. So base height ratio, when we erect scaffold, always if the height exceeds 4 times from the smallest width of the scaffold. So over here you can see the scaffold where it has 5 feet width, the smallest width. So the scaffold height maximum we can exceed 4 times from that width. So 405 is 20 feet. If the scaffold height goes more than 4 times from the base ratio, smallest base ratio, the scaffold has to be tied on a structure or supposed to be supported with rackers, or else we need to make sure the base ratio has to be increased as per the height requirement, and so we can make sure the scaffold won't collapse. So we'll be having different types of tie which will be helping us to support the scaffold when the height ratio increases. And even in the height ratio, I always used to recommend inside the building when we erect the scaffold, we can go for 4 times. The height can go 4 times from the width of the scaffold. If it is outside the building where we will be having too much wind, vehicle movement, vibrations, I always prefer the height to be limited 3 times from the width of the scaffold, or else we need to follow proper diagrams, calculations over there. So in case if the height increases, we can have different types of ties: thorough tie, box tie, rackets, reveal ties, eye bolts, lip ties. So it will help the scaffold from collapsing. So this ties, as it shows in the page, one of the options is box tie. It's a heavy duty tie. Then we have lip tie, we have thorough tie, we have reveal ties, reveal anchor ties. So each 4 meter vertical and horizontal we need to give tie. So the structure will be supported. If the height goes above 4 times from the width, or we need to install rafters to support the scaffold. I hope the answer is clear.
Okay, we've got one more question, but I think you may have just answered it. What will be the maximum height that we can make for a 1 meter base scaffold? Maximum width,
4
sorry,
meter.
width, not height. So
Maximum width of the scaffold. Width depend upon the location we can have the scaffold. Depend upon the location, 1 meter, 2 meter, 3 meter, as per the height which we required, we can have the scaffold. As it shows, we have birdcage scaffold where you can see length and width is big, so big. So there is no limitations in scaffold, the width and length. Always is as per the design and as per the purpose. What is the purpose of the scaffold is going to be? Light duty, medium duty, heavy duty.
Okay, we've got another question. What could be the best method to shift hand tools and other kind of small materials to the scaffold platform?
scaffolder is back. We can install gin wheel. There is a element available, gin wheel, which we can install on the scaffold platforms, near to the platforms. So we can input the materials on the back, and we can use the gin wheel to pull the materials up.
Okay, thank you. We've got more questions now. In a situation where the ground level is not equal, what kind of scaffold can we use?
We can use tube-and clamps as well. We have to use base jack. That is the main thing. We have to use base jacks, and we can use tube and clamps. The advantage of tube and clamps is we can install ledges anywhere as it's required. When it comes on system scaffold, there are particular places where we have to put the ledges. Couple of means the ledger has to go in that particular area. So the adjustment is going to be very tougher. But at the same time, if it is on tube and clamp, it is more easier for us.
Okay, thank you. And then is the 3 times of shortest width QCS 2014 guideline? Does that make sense?
2014 guidelines, it says 4 times from the width. 3 times. I have read some approved guidelines which is suggesting for us to 3 times from the width, where we have wind ratios and vehicle movement vibrations.
Yeah, he said it's about freestanding scaffolding where width to height ratio is applied.
Yes.
Yeah.
Okay. Freestanding scaffolds.
Okay, we'll take the last question now, if that's okay. What should be the safe distance for excavation to start from scaffolding tower? Any reference to QCS or BS standard?
There is no reference. We have to do a risk assessment over there. Depend upon the soil condition, depend upon the depth of the excavation. If you're following regulation, as per the regulation, they say from the depth of the scaffold, 1.5 times higher the distance has to be. Even a vehicle scaffold, any movement, supposed to be 1.5 times from the depth. If the depth of a excavation is 2 meters, the distance from the excavation tip 3 meters, we have to maintain the distance. But you can see in many places it's not possible because of the location and because of our work locality. So over there, we will be using engineering designs. We will be using shoring methods, bending methods inside the scaffold to protect cave-ins. So in those locations, as per the risk assessment, we can decide the distance from the excavation.
Thank you, Deepu. That was the last question. Thank you for a really informative webinar. I'm sure everyone else found it as interesting as I did. Just to let everybody know that the recording will be uploaded onto the IIRSM YouTube channel in the next day or two. So I want to thank Deepu for giving us the presentation today, and thank everybody for attending, and we hope to see you at the next meeting.
Yes, thanks a lot, guys. Thanks for attending this session.
Good evening, everyone.
And good evening. Bye-bye. Have a safe day.
Bye.
Bye, Judy.